Okay, conditional probability of two independent events. Now this is to do with things that aren't related to each other. And these are when I give you examples, I will make sure that they are clearly independent. Some things it's not sure whether they're independent or not, and that's why you would do an experiment to find out, or you'd find things out. But in some of these rules apply only for independent events. I think it's beyond the scope of this course to move on to the other ones, so we're just going to do that. So 5% of nuts in the bin are faulty and 2% of the bolts are faulty. Okay, so a nut is a thing like this, not the things that you eat, but like that, and it's got a little thread inside, and then we have a bolt which is sort of like this, and it's got thread there, and you've got a little thing on the end or whatever. Okay, so 5% are faulty, 20% of the bolts are faulty. You are pairing up a nut with a bolt. What is the probability that both of them are faulty? So you have the probability that the nut is faulty and bolt faulty, and means multiply faulty. So that equals 0.05, 0.05 times 0.02, which equals 0.001. So very, very low. What is the probability that two people drawn at random from a population both have their birthday in March? And that's assuming that each month is equally likely, which isn't actually true, because we all know September and August are far more popular months to be born in. Okay, in the southern hemisphere. So the probability that person A is born in March is 1/12. The probability person B is born in March is 1/12. And the probability that they're both born is 1/12 times 1/12, which equals 0.00694. The bizarre thing is that once you have 30 people in a room, the probability that at least two of them have the same birthday is very, very high. And I can't remember why that is. Okay, let's have a look at this example here. Okay, I'll give you a minute to have a look at it and see what you would do for this one. Okay, to start off with, I've used the rule of complementarity here. Is that basically the plane ticket will either increase or it won't, and the uncle will pay or he won't. So those probabilities individually add up to 1. So price increase plus no increase adds up to 1. Uncle pay, uncle doesn't pay adds up to 1. And so then we want the probability that the price increase and uncle not pay equals price increase is 0.4 times uncle not pay 0.8, which equals 0.32. So that's sort of the worst outcome. He's going to have to pay more and nobody's going to help him with him, so the chance of that is 0.32. And this one here, I'll just put the answer down here. It's going to be 0.4 times 0.1, which equals 0.04. Right, good luck, and I'll see you next week for the rest of probability.